Hello everyone and welcome back to Coding with Mock. In this video, we'll be having a quick look at the life cycle of a Java thread. Now, to start off, this is going to be a simplified view. In later videos, we'll be having a look at some other states our Java thread can be in. But for now, these are the states that we will be looking at for our Java thread. Now, there's three thread states that our thread can be in. Okay, and hopefully this will also explain a little bit why we had that delay when we started our thread and before it actually got started and actually started doing the work. Okay, now when we create our thread object, it gets the new state. Okay, this tells our scheduler, and we'll be looking at the scheduler in a minute. But this tells our scheduler, okay, this is a thread, but I don't have to do anything with it yet. Okay, yet. That's the operative word there. So I create a thread object. At that point in time, it is in a new state, and it doesn't do anything yet. Now, we've also seen that if we want to actually get our thread to execute or to start running, I have to call the start method. And once I call the start method, my thread goes to a runnable state. This runnable state tells the scheduler, okay, this thread is ready, and you can start executing this thread whenever you feel like it. And that's really important to understand. The scheduler, we don't have any control over the scheduler. Just like we don't have any control over the garbage collector in our virtual machine, we don't have any control over the scheduler. Well, little to none. Okay. Once you become an accomplished developer, you will learn that you have a modicum of control over the scheduler, just like you have a modicum of control over the garbage collector, but it's not really control. Okay, something you need to remember. So we call the start method, which places our thread in a runnable state, and then it gets picked up by the scheduler. The scheduler will actually start executing our thread when it feels like it, and then my thread will start running. Now, it will still be in a runnable state, but we call it running for now. We'll get to that later. Okay, so runnable state gets picked up by the scheduler and starts running, which is not really a state. Then, when our run method reaches its end, so at the end of the run method, our thread object will place itself in a terminated state. Also important, and I'll show you why in a minute. Okay, so we start out by getting a new state. Then when we start our thread, it goes to a runnable state. The scheduler then picks it up and it keeps it in a runnable state, but it starts executing that thread. And then when it's done, it places itself in a terminated state. Okay, now let's have a quick look at what that looks like in code. I've written a little quick program. It's still our counting thread for simplicity's sake. I have thread T1 here, which is a counting thread. And then I'll ask my counting thread what its state is and print that out to the console. Then I'll start my thread. And immediately after that, I'll check what the state is at that point in time. Then 10 milliseconds later, ask it again, what's your state? And then at the end of the program, after 1 second, don't actually need this. Okay, I'll ask it again, what's your state? Okay, let's run this program and see what happens. And there we go. So you can see immediately at the end of our application, when my thread is done, it's in a terminated state. Let's go all the way up. And here you can see my first system out. That's this one here. That's this. When I create my thread, it doesn't get executed. It's in a new state at this point. And my scheduler will ignore new thread, right? Because they're not ready to be executed again. To be executed. Now, once I start my thread, and that's my second output here, that's this one, I'm in a runnable state. Then my thread starts executing. And then 10 milliseconds later, I asked it again, what's your state? And if we scroll down, I've already spotted it. It was around 700, maybe, oh, no, 800. Here we go. This is 10 milliseconds later. My thread is still in a runnable state, but it's actually executing. And then at the end, once my thread comes to a close, my thread was done here, and 1 millisecond later, my main thread wakes up again and asks, okay, T1, what's your state? And that's the terminated state. Okay, so hopefully that explained a little bit why we got that delay, and this will become more important, these states, when we start looking into concurrency problem, but that's for a next video. Now, to finish with, there's one more thing I want you to know about threads and why we keep states. This terminated state is a really important one because it says, okay, this thread is done. It has done its work. Now, why is that important? Let's try and restart our thread. Let's have a look. And you can see here, I get an exception now. What's the exception? Namely, an illegal thread state exception, and actually says, what this says is, my scheduler or my thread can't be started or can't be restarted because it's in an illegal state. It has to be in the new state to be started. Okay, to get it from, or to be able to call the start method, it has to be in a new state. If it's in any other state, we'll be getting this exception. Okay. This is done for a lot of reasons, a number of reasons, but we don't want to repeat our work accidentally. So what we need to do if we want to redo some work is we have to recreate the thread, start that new thread or that new thread object. Okay, so but important to remember here is a thread can only be executed once. Okay, once it's terminated, you can't re-execute it again, and that's why we also keep the state at the end of a thread. Once my thread is done, it's terminated, and I can't start it again. Okay, good. Now, in the next videos, we'll be going to be looking at some problems that we can have with thread. But that's for the next video. Okay, hope everybody's healthy. See you in the next video.